Most people assume that making AI smarter required some brilliant algorithmic breakthrough. The honest version is simpler and stranger. Someone plotted a graph, and the line just kept going up. Here's what most explainers miss about the AI race. The biggest bet in the industry, hundreds of billions of dollars worth, isn't on a clever new technique. It's on a set of empirical curves discovered around 2020 by researchers at OpenAI. They found that AI performance improves as a smooth, predictable function of scale. Not in dramatic leaps, not through architectural revolutions, through sheer volume. And that finding changed everything about how AI labs allocate resources. So here's how it actually works. There are 3 levers you can pull to make a language model better. The number of parameters, roughly the model's capacity to store patterns, the amount of training data you feed it, and the compute you spend during training. What the scaling laws showed is that each of these independently improves performance along a power law curve. Double the compute and the error drops by a consistent, predictable fraction. This relationship held across 5 orders of magnitude, a factor of 100,000, which is extraordinary for an empirical result. But here's the nuance. Bigger isn't always better per dollar. In 2022, DeepMind's chinchilla paper demonstrated that most frontier models were oversized and undertrained. A smaller model trained on more data could match a model 4 times its size at a fraction of the cost. That insight, compute optimal training, reshaped the entire field's strategy overnight. Then there's the part that still isn't fully understood. At certain scales, models don't just get incrementally better, they unlock entirely new capabilities. A model that couldn't do basic arithmetic at 10 billion parameters suddenly can at 100 billion. These emergent abilities appear as if a threshold was crossed, even though the underlying loss curve is smooth. Whether this is a genuine phase transition or a measurement artifact is still actively debated. And that brings us to the open question. The curves have held for years, but nothing guarantees they hold forever. We may be approaching limits in available training data, in the energy cost of compute, or in what statistical pattern matching can ultimately achieve. The honest answer is nobody knows yet where the ceiling is, or if there is one. What this means for you is concrete. Every time a new model drops and seems surprisingly capable, it's not magic. It's the scaling laws still paying off. Understanding that curve is the single most useful lens for predicting where AI goes next. If that was useful, subscribe. New explainer every week. I'm Ariella,